Today we're going to look at the last topic in Chapter 2 and Math 30-1, and that's solving radical equations both graphically and algebraically. First thing we're going to do is we're going to relate the roots and x-intercepts. Determine the roots of the square root of x plus 5 minus 3 equals 0 algebraically. Well, in order to solve this equation, we're going to add 3 to both sides to get the root of x plus 5 is equal to 3. Now we can square both sides, and that's going to leave us with x plus 5 is equal to 9. Subtract 5 from both sides, and we'll have x is equal to 4. So x is equal to 4 is the root, or what we call the solution to our equation. Now, if we're using a graph to determine the x-intercepts of y is equal to the square root of x plus 5 minus 3, there's the graph. Notice that the x-intercept of the graph is at 4. X equals 4. And that means that the root of the equation and the x-intercept are going to be exactly the same thing. Algebraic solutions will sometimes produce what we call an extraneous solution, one that doesn't work. Whereas graphs will not. They will always just produce the solutions, the x-intercepts, that work. However, algebraic solutions can be more exact. Graphs are only going to produce a decimal approximation of the answer, whereas an algebraic solution, you'll be able to determine the exact answer. Let's look at another example. In example 2, we're asked to solve the square root of x plus 5 is equal to x plus 3, both algebraically and graphically. Well, first of all, when we write that equation, we're going to square both sides, and that's going to give us x plus 5 is equal to x plus 3 times x plus 3. X plus 3 squared means that we're going to have to FOIL it, and that's going to leave us with x plus 5 is equal to x squared plus 6x plus 9. Now if you bring everything over to the one side by subtracting an x from both sides and by subtracting 5 from both sides, you're going to get x squared plus 5x plus 4. Now here we have a quadratic equation. There's several different ways we can solve this quadratic equation, and one of the ways is by factoring it. By factoring it, we need to find two numbers that multiply together to give us the last term, 4, but add up to get the middle coefficient, which is 5. And that's going to be 4 and 1. So we're going to say one of the factors is x plus 4 and the other one is x plus 1. That means that our solutions to our equations are going to be x is a negative 4 or x is equal to negative 1. However, if we graph this, or if we try to verify this, we're going to see that one of these solutions doesn't work, doesn't exist. That'll be what we call the extraneous root. So if we verified it by substitution, we're going to take our original equation and plug negative 4 in for x. That'll give us negative 4 plus 5 is equal to negative 4 plus 3. On the left side, we're going to get the square root of 1, which is 1. And on the right side, we're going to get negative 1. So, no, that won't work. If we tried it again with negative 1, you're going to find that the square root of negative 1 plus 5 has got to be negative 1 plus 2, or 3, which means that 2 will equal 2, so yes, that one does work. So there's only one solution. X equals negative 4 is what we call an extraneous root. X equals negative 1 is the only root for this equation. Now, to graphically solve this, what we're going to do is we're going to set y1 to equal the left side of our equation, root of x plus 5, and we're going to set y2 to equal x plus 3 in our graphing equation, and then we're going to try to find the intersection point of these two graphs. So here's what the picture is going to look like. That was x plus 3, and the other one is the root of x plus 5. Notice that the two graphs are only going to cross in one spot, and that is when x is negative 1. Whoops. And that's all I got to say about that. Let's move on to the next one. In our next example, approximate solutions to radical equations are going to be found graphically. So what we're going to do is we're going to solve this one graphically by putting it in our calculator and seeing what we get. When we're asked to express it to the nearest tenth or hundredth, all we got to do is use our calculators. y1 will equal the left side, y2 is going to equal the right side. Now when you plot it, you're going to find the intersection point. Notice that there's two. One of them is going to be when x is 5.81, y will equal 9.81, and when x is negative 1.81, y will equal 2.1. So those are the two solutions for this radical equation. Sometimes there'll be one, sometimes there'll be two. Now, these solutions, as you can see, as I said, are negative 1.8, 5.8. Now we're asked to verify this by solving the same equation algebraically. Well, let's write down the equation. First step is going to be to square both sides, because we have isolated the root on one side. That means 3x squared minus 5 is going to equal x plus 4 times another x plus 4. Or 3x squared minus 5 is going to equal x squared plus 8x plus 16. Now we have to bring everything over to the one side. Back this up. And you're going to get, by subtracting an x squared from both sides, you're going to get 2x squared. Subtract 8x from both sides, minus 8x, and subtracting 16 from both sides, minus 21 is equal to 0. So now what you have is an equation, a quadratic equation. It's not factorable, so we're going to solve it by using the quadratic formula, which means that x is going to equal negative b divided by, plus or minus the square root of b squared minus 4ac divided by 2a. Now remember, from our equation, a has a value of 2, b will have a value of negative 8, and c will have a value of negative 21. So x is going to equal 8 plus or minus the square root of 64 minus 4 times 2 times negative 21 divided by 2 times 2, which is 4. And it'll give you 8 plus or minus the root of 232 divided by 4. And if you had to express this as an exact answer, we would reduce root 232. To do that, you'd find the biggest perfect square that you could divide into 232, and that could be 4. So it would be root 4 times root 58, which then we'd express as 2 root 58. So now it's going to be 8 plus or minus 2 root 58 divided by 4. Now I can divide the top and the bottom both by 2, and you would get 4 plus or minus root 58 over 2. That is the exact answer. Now, the decimal approximation of this is only going to go to 4 plus root 58 divided by 2 and 4 minus root 58 divided by 2. And those you already know, those are 5.8 and negative 1.8, the same as we got by graphing. However, we have now verified it algebraically. Your turn. This time, what we're going to do is you're going to do these three. In the first one, you can stop now, do these, and then come back and correct them. And as we correct them, you're going to see there are the three solutions. Your assignment for this section is to do page 97, numbers 1 to 7.